Hello students, this is Mrs. Crumpton. We're going to be covering two sections, and the first section is from your Glencoe Algebra 1 book, section 8.1, Adding and Subtracting Polynomials. Your learning target: I can write polynomials in standard form, and I can add and subtract polynomials. From page 465 of your text, there are some vocabulary terms that you need. The first term is polynomial. A monomial are the sum of monomials. A binomial is the sum of two monomials. A trinomial is the sum of three monomials. The degree of a monomial is the sum of the exponents of all its variables. The degree of a polynomial, the greatest degree of any term of the polynomial. Okay, students, we're going to take those definitions now and we're going to apply them and figure out how to work some problems. We are going to determine whether each expression is a polynomial. Now, check back in your notes, and I'm going to flip back in my book and make sure I read the definition correctly. The definition for polynomial is a monomial or the sum of monomials, each called a term of the polynomial. Now, this is from page 465 of your textbook. Determine whether each expression is a polynomial. If it is a polynomial, find the degree and determine whether it is a monomial, a binomial, or a trinomial. First thing that we're going to do is we're going to look at A here, example A. Now, is this a polynomial? Is it a sum or a difference? Remember that subtraction is just addition of the opposite. So is this a polynomial? I hope you said yes, because it is. And I want us to determine first, before we determine the degree, is this a monomial, a binomial, or a trinomial? Now, a monomial has one term. A binomial has two terms, and a trinomial has three terms. How many terms is in this problem? Two. So this is a binomial. Think about a bicycle. A bicycle has two tires. A binomial has two terms. Now let's talk about the degree. We're going to find the degree of the polynomial here. You want to look at the variable, and you want to look at the exponent of the variable. Although we don't see it, that exponent is 1. So the degree of this polynomial is 1. And let's move on to the second problem. Is this a polynomial? Yes or no? I think I hear some of you saying, it's a polynomial, and you're right. It is polynomial. Now, is it a monomial, a binomial, or a trinomial? How many terms does it have? It has 3 terms. That makes it a trinomial. Like a tricycle. Tricycle has 3 wheels. A trinomial has 3 terms. Now let's talk about the degree. Look at your exponents here. This exponent has a 2. The exponent of this variable is 2. So my degree for this polynomial is 2. Okay, let's go on to this problem. In problem C, what do you see? What do you see in C? I see division, and I see a variable in the denominator. So this is not a polynomial, and we don't have to worry about the degree, because we are only finding the degree of the terms that are polynomials. Okay, how about this last one here? Polynomial or not? Think back to your definition, and your definition says that a polynomial can be a monomial. A monomial is an expression with one term. This expression does just have one term, so it is a polynomial. Monomial. And what is the degree of this monomial? Degree 2. Look at the exponent. Okay? Now these will help you do a few problems in this section, and we're going to do some more. I'll give you some more examples in just a second. Students, for the next examples, you're going to need a couple more definitions. Here we have the standard form of a polynomial. The terms are in order from least to greatest, and your leading coefficient is coefficient of the leading terms. These definitions can be found on page 466 of your textbook at the top of the page. Okay, students, we are going to write each of these polynomials in standard form, and we're going to identify the leading coefficients. Now, to write this in standard form, I need to look at the exponents. Although I don't see it, do you remember what the exponent for this variable is? It is 1. Now, we need to look at which one of the exponents on these variables is the largest. Since 6 is the largest exponent, we're going to start with this term, this monomial. Since it's positive, we're going to write that as 3x to the 6th power. Next is our 9x squared. That is also positive, so we're going to write that as 9 plus 9x squared. And then the last term is going to be minus 4x. It's that easy. And our leading coefficient here, the coefficient of the first term, is 3. Let's go to this one. I'm going to give you about 5 seconds, 10 seconds head start on me. See if you can do this one. Might be a little tricky with 2 exponents, but I think you can handle it. Got an answer for me? Let's see what you got. Leading coefficient. Now I've got x's and y's, but I want you to notice here, these x's have the same exponent. So we're going to look at the exponent for y. Which one of these terms with y has the largest exponent? It's going to be this last term here, 8xy to the 2nd power. Okay, now we've got a term here that's got a y, and we know that y is the same. Because both of these have 1 for their exponent. However, this one also has an x, so it is going to be your second term in this polynomial. Our third term is going to be the term with just a y by itself. And our last term is going to be the constant. What's your leading coefficient here? Look at the coefficient of the first term. What do you see? Hope you find an 8, because that is the leading coefficient for this polynomial. Okay, students, now we are going to find each sum of polynomials. Now, this is pretty easy. I want you to think back to when we were combining like terms a long time ago. That's all we're going to be doing for this. Now, there are 2 methods to do this. You've got a vertical method or a horizontal method. Now, I like to use the vertical method, and I like to line these up. So what I'm going to do is I'm going to pull this out of parentheses. I've got 7y to the 2nd power plus 2y minus 3. Okay, now I've got this listed in order from greatest to least as far as our terms go. This is our standard form for a polynomial. Now, I want to look up here at my second polynomial. By the way, binomials, trinomials, or monomials. This is a trinomial, and we're adding it to another trinomial. Okay, now I want to take and I want to line up the like terms. Since this is plus or adding or the sum, it's going to be real easy to do. Over here, I have a 5y to the 2nd power. So I'm going to simply line this up, 5y to the 2nd power. Now I'm done with that term. I'm going to come on to negative 4y or minus 4y. I'm going to line it up under its like term. And then last but certainly not least is our constant. Since this is a positive 2, I'm going to put plus 2 under its like term. Draw a line under there and add these. Now when we are adding like terms, we don't do anything with these exponents. They stay the same. We add the coefficients. So 7 plus 5 is 12. Y to the second power. 2 minus 4 would be negative 2. Don't lose y. And then negative 3 plus 2 is negative 1. It's that easy. You can also use a vertical method in which you would just leave these where they are and match up your like terms. Now, how I do that is I use different shapes. I would put a box around these two terms because they're like, and I might use an underline under these two terms because they're like, and I might use a squiggly under the constants because they're like. Either way, you should get the same result. Okay, now the next thing we're going to do is a difference. Okay, students, now we're going to find the difference of polynomials. Now, finding the difference is a little bit different than finding the sum. Now, the first thing I want to do is I want to take this first trinomial and I'm going to list it from greatest to least as far as my terms go. I'm going to start with the 8y to the 4th. Since this is positive, it goes next. The exponent's 2 is actually why it goes next. And then minus 5y. Now, the one thing that's different about finding the differences than finding the sum is we've got to go back to our old friend Mr. Distributive Property. And we're going to take that negative sign first before we do anything else. And we're going to hug everybody in the house. Also distribute the minus sign. So here we're hugging with the minus sign, hugging with a minus sign, hugging with the minus sign. And so we're going to have, and I'm going to space this out just a little, we're going to have negative 9y to the 4th plus 7y minus 2y to the 2nd. Now I'm going to list these in order from greatest to least. This one's in the right spot. And moving this one to the correct place, and 7y. Now, since we've done our distributive property and we've taken care of that negative sign, all we're going to do is stack them up just like we did for addition. Remember, I told you before that subtraction is just adding the opposite. Well, that's what we're doing here. So I'm going to line these up. Minus 9y to the 4th minus 2y squared plus 7y. And we're going to do the same thing that we did before. 8y to the 4th minus 9y to the 4th would be 1y to the 4th. Remember, that 1 needs to be an imaginary one. We don't have to show that. 6y to the 2nd minus 2y would be 4y to the 2nd. And finally, negative 5y plus 7y would be plus 2y. How'd you do on that one? If you would like some more examples of these two problems that we've just done, you can find adding polynomials on page 466 in example 3 and subtracting polynomials, page 467, example 4. Students, here's a real-world example of how we're going to use polynomials, or how you might use polynomials. The total cost of toy sales T in billions of dollars consists of two groups: sales of video games V and sales of traditional toys R. In recent years, the sales of traditional toys and total sales could be represented by the following equations, where N is the number of years since 2000. R equals 0.46 n to the third power minus 1.9 n to the second power plus 3n plus 19. T, remember T is our total sales, 0.45 minus, 0.45 n to the third minus 1.85 n to the second plus 4.4n plus 22.6. Now what we're going to do with this is we're going to write an equation that represents the sales of video games, V. Now, we're interested in the video games. We've been given an equation for the total sales and the sales of traditional toys. Now, if they're adding traditional toys and video games in order to get this total, what operation are we going to have to do to get just the video game sales? Think on that for a second. Are we going to add these? No, we're going to subtract. So I'm going to take my total sales, T, and I'm going to write that up here. 0.45 n to the third minus 1.85 n to the second plus 4.4 n plus 22.6. Now since we're subtracting, what we're going to do is we're going to go back to this equation over here for just a second. And we're going to have to use our distributive property, and we're going to distribute a negative sign to each one of these toys here, the R, which is the traditional toys. Remember, that's how we do the difference, since we've got a difference. Okay? Now, once we distribute that, they're already lined up on top with our like terms. Distributive property gives me negative 0.46 n to the third plus 1.9 n to the second minus 3n plus, not plus, that should be minus. Okay, pause the video for just a minute and see what you get for your answer. Let's check your answer. When we subtract this, you're going to get negative 0.01 n to the third power. When we subtract these two, we're going to get positive, I'm going to cheat and look at my book, 0.05 n to the second here. We're going to get 1.4 n. And lastly, we get plus 3.6. How'd you do on that one? Okay, that's a real-world example for adding and subtracting polynomials. Next, we're going to roll into our second section of this video, which is multiplying polynomials. Okay, students, I'm going to do a second video for section 8.2. Your formative assessment for section 8.1, page 468, numbers 1 through 5, and numbers 11, 13, and 19. Remember, this is just a snapshot and gives me an idea if you understand what I've shown you so far. Your heads-up assignment. This is what you'll be doing in class. Is going to come from pages 468 through 469. We are going to do problems 21 through 44, 21 through 43 odd. In addition to those problems, you will do number 51. Okay, see you in class.